Every single year, thousands of research papers get published on the same topic: cancer treatment, mental health therapies, vaccine effectiveness, and here the crazy part: they often contradict each other. One study says drug A works, another says it doesn't. A third one says it depends. So, how does a doctor, a policymaker, or even a patient know what to actually believe? That's exactly what a systematic review is designed to solve. And by the end of this video, you are going to understand not just what it is, but why it's considered the highest form of evidence in science. Every single year, thousands of research papers get published on the same topic: cancer treatments, mental health therapies, vaccine effectiveness. And here's the crazy part: they often contradict each other. One study says drug A works, another says it doesn't. A third one says it depends. So, how does a doctor, a policymaker, or even a patient know what to actually believe? That's exactly what a systematic review is designed to solve. And by the end of this video, you are going to understand not just what it is, but why it's considered the highest form of evidence in science. So, what exactly is a systematic review? At its core, a systematic review finds, evaluates, and synthesis all available evidence on a specific question using a rigorous, transparent, and reproducible method. All available evidence, not just the studies that support your hypothesis, not just the one that are easy to find on the Google Scholar, all of them, including unpublished ones, studies in another languages, grey literature, everything on a specific question. This isn't a general overview of a topic. A systematic review answered one precise, predefined questions, and using a rigorous, transparent, and reproducible method. Using decisions is documented so another research could repeat your exact process and get the same. Now, you might be thinking, isn't that just a literature review? Great question. And that the answer is absolutely not. A traditional literature review is essentially you going to the library, reading papers on a topic, and summarizing what you found. The process is informal. You probably didn't document your search terms. You might have unconsciously selected papers that supported your argument. A systematic review is fundamentally different. It has a pre registered protocol published before you even start searching. It uses a comprehensive documented search strategy. It has explicit inclusion and exclusion criteria. It involves at least two independent reviewers screening every single. Let me give you an analogy that I think make this really click. Imagine you are a judge on a courtroom. A very important case is in front of you, and your verdict will affect thousands of people. You have two options. Option 1: you ask a few lawyers to tell you what they know about the case, and each one tells you their version, and the stories don't quite add up. You make your best guess. Option 2: you commission a forensic team. They go out and gather every piece of available evidence systematically, thoroughly, transparently. They document every step. Two investigators independently verify every finding. Which verdict would you trust more? That's exactly my systematic review exists. When healthcare systems are deciding which treatments to fund, when the World Health Organization is writing guidelines, when a government is setting public health policy, they need the forensic approach. They need a systematic review. And this is why systematic review sit at a very top of what's called the evidence hierarchy. the pyramid of evidence quality in health research. Above expert opinion, above observational studies, above even randomized controlled trials. A well conducted systematic review of multiple high quality trials is the gold standard of evidence. It is the most reliable, unbiased answer to a research question that we can possibly get. When the World Health Organization published a guideline, when NICE recommends a treatment, when a government funds a health intervention, they base it on systematic reviews. That's how important this is. Let me quickly walk you through the six key components of a systematic review. 1. The researcher questions structured using the PICO, that is PICO framework: population, intervention, comparison, outcome. For example, in adults with type 2 diabetes, the population does metformin. The intervention could be compared to placebo, and the comparison reduced HbA1c level. That's the outcome. So, PICO keeps your question precise. 2. The protocol: before you search a single database, you write and register your full plan on Prospero. This is what makes it transparent. Third, the systematic search. You search multiply databases: PubMed, Embase, Cochrane, Scopus, using a carefully built search strategy. You also search gray literature. 4. Screening and selection. Two reviewers independently go through every search result and resolve disagreement through discussion. 5. Data extraction and quality assessment using a validated tools like the Cochrane Risk Bias tool. 6. Synthesis, either a narrative summary or a meta-analysis where you pull the data systematically. And that's a whole series on its own. So, let's bring this together. A systematic review is a rigorous, transparent, and reproducible method of finding, evaluating, and synthesizing all available evidence to answer a specific research question. It's not a literature review, it's a structured scientific process with a pre registered protocol, a comprehensive search, independent screening, quality assessment, and a formal synthesis. And it sits at the top of the evidence hierarchy because it gives us the most reliable, unbiased answer that we can possibly get. If you found this helpful, hit that like a button, subscribe so you don't miss episode 2, where we go deep on how to write a perfect Pico question with real example. Drop in the comments what topic are you hoping to do a systematic review. I read every single one. See you in the next one. Thank you.